This time we're going to talk about concentration and dilution of that solution that you've made. So if I were to tell you to look at these two glasses of tea up here in the top left corner, and I said, tell me the difference in these two glasses, you would probably tell me, well, the one on the left is strong and the one on the right is weak. All right, but as scientists, we are not going to use the terms strong and weak. Instead, we are going to refer to them as concentrated and dilute. So when we talk about concentration, that's what's measuring the amount of solute that is dissolved into our solvent. So a concentrated solution has a large amount of solute. So think about sweet tea. The more sugar you put in, the more concentrated it's going to be. Another example would be shampoo. All right, if you ever look on the side of the bottle, it'll probably say it is concentrated. That's why it only takes a maybe dime size amount to wash your entire head of hair, because it is a very concentrated solution. There's a large amount of solute, a large amount of soap packed into your solution. And then you have dilute solutions. That means there's a small amount of solute. So think about household cleaners as you start to run out. What might your mom throw into it to get that last little bit out? Probably mix it with some water, dilute it out, and use the rest of it that's in the bottle. So then that would be a dilute solution. Another example, if you go out to eat with family and you maybe have younger siblings and they ask the server to put some water in with the orange juice or the apple juice, that is helping dilute out the juice and making it to be a small amount of solute or a small amount of juice or sugar in that solution. So then molarity is going to be what measures our amount of concentration in a solution. Molarity can be abbreviated with a capital M. All right. Molarity, the formula is molarity equals moles over liters. Remember, we can turn that into your magic triangle where moles is on the top and molarity and volume are on the bottom. Remember, whatever you cover up, if I'm solving for volume, it would be moles over molarity. And if I was solving for molarity, then it would be moles over volume. And lastly, if I was solving for moles, then it would be molarity times volume. All right, so we should all be pretty familiar with that math triangle there. So let's look at an example. If 2.0 moles of NaCl are dissolved in 1 liter of solution, of H2O, what is the molarity of the solution? So 2 moles over 1 liter of volume would be 2 divided by 1, which is 2 molarities. All right, example 1, that was a pretty simple one. Let's flip and go to example 2. Now it says how many liters are in 20 moles of a 3 molar solution. So it'll help to identify those as you're going through your problem so that you can then plug them into your equation. So I'm looking for my volume. I have 20 moles and a 3 molar solution. So 20 moles divided by 3 molars would be 6.67 liters. All right, so let's take a look at 2 more examples. These are going to incorporate some skills that you all learned in Unit 5. So again, I'm going to write over here in our corner, what is our triangle? For molarity, you have moles over molarity and volume. So let's take a look at number 1, identify what they have given us. It says, what is the molarity, capital M, of a solution that contains 50 grams of NaCl in 0.6 liters of water? So there's our volume. So if we look back over at this triangle, they have given me volume. My volume is 0.6 liters. And I want to find molarity. Therefore, I need moles in order to solve for molarity. But I don't have moles. What do I have? I have grams. All right. But as we know from Unit 5, I can go from grams to moles. All right. And how do we do this? Does anybody remember what's that base unit for grams? It is the molar mass of the substance, using the molar mass of substance. So what is our substance in this case? It is NaCl. The weight of Na is going to be 23 grams when you look on your periodic table, and the weight of chlorine is 35.5. So when we add those together, my molar mass of the substance is 58.5 grams. All right, so now I can use that and take this 50 grams and convert it to moles. So I'm going to write out that 50 grams here. That is my given value, 50. And I am trying to convert to moles, for which the base is 1. So remember from Unit 5, whatever goes up, which is up here at our grams, must come down. So that's where our molar mass is going to go. Plug that in there, and we have 58.5 grams. And now our grams will cancel out, and I'll be left with moles. So once I multiply across the top, divide by the bottom, I have 0.8547 moles of NaCl that are present in 50 grams. All right, so now I can use this moles and plug it into my triangle so that I can solve for molarity. All right, so let me switch the color here so we can see it better. So now I can take this amount of moles and I'm going to plug it in up top in that triangle, 0.8547 moles over my 0.6 liters is going to give me my molarity. This is the same exact triangle that I drew up there in that top right so that you can see it a little clearer and a little bigger. All right, so once I do my 0.8547 divided by 6, I get a molarity of M equals 1.42 molars. All right, so again, there you go, from grams to moles. Made that conversion so that we could plug it in and find our molarity. All right, now let's take a look at example 2 down here. Again, I'm going to write in the bottom corner here our triangle so that we can see it for reference. We have moles over our molarity and volume. All right, so let's go ahead and identify what they've given us. It says how many grams of CaCl2 will be dissolved in a 3.0 liters of 0.1 molar solution. So we have grams, which is our mass, we have liters, which is a volume, and then we have our molarity. So when we go to plug that into our equation, I have molarity, I have volume, so then I can solve for moles. So let's go ahead and do that and plug those in. I have moles over a molarity of 0.1 and 3 liters. So then that gives me how many moles? That gives me 0.3 moles. All right, so that's the answer that it gives me, but what did they ask me for? They asked for it in grams. So just like we did a second ago, now we are going to go from moles to grams. And how do we do that? By using the molar mass. That's what you all need to remember when we're converting between those two. You are using your molar mass. So if we look at CaCl2, you have a mass of 40 for Ca, and then for Cl you have 35.5 plus 35.5. Why did we put that twice? Because there are 2 chlorines. This should be a subscript. However, the text on this iPad wouldn't let me put it as a subscript, so please know that this should be a little 2 down at the bottom. So you have 2 chlorines. Once you add together the molar mass, you have 111 grams. All right, so going from moles to grams, we're going to plug in what we have, 0.3 moles, and I want grams. All right, whatever goes up must come down, so that means I need to put 1 mole at the bottom. Whatever goes up must come down. That way they can cancel out. So the grams that I just found was 111. So 0.3 times 111, you have 33.3 grams of CaCl2. All right, and so that's your answer there. If you see what we did, all we did was we plugged it into our triangle down here in the bottom corner, and that gave us moles. Then we took our moles and converted it to grams using the molar mass. All right, so last thing here, we're going to talk about dilution and our dilution formula. So what do you do if your sweet tea is too sweet? You're going to change the molarity of it. You're going to change the dilution of it. So therefore, you're going to change the volume of your solution. You're going to add some more water, dilute it out so that it's not as sweet, right? So how you're going to do that, we're going to compare our starting molarity. So capital M stands for molarity and the V stands for volume, right? So we're going to compare your starting molarity and your starting volume with your final molarity and volume. Remember, V1 stands for initial and V2 stands for final. So let's look at example 3 here, which is the first example of your dilutions. If 2 liters of this is our volume, 2.5 molar solution, so V1, M1, is increased to 5 liters, there's V2, what is our new M2? All right, so again, here is our equation. And all you're going to do, now that you've identified your variables, is plug those into your equation. So for M1, I have 2.5 times V1 of 2 equals my M2 V2. All right, so simplify over here. 2.5 times 2, I have 5 equals M2 times 5. How do I solve for M? I'm going to divide by 5 on both sides, and those 5 cancels out. And I have 1 M equals my molarity. Pretty simple example there to start with. So 1 equals my molarity in this new instance. All right. So let's take a look at 2 more examples. What is the original volume? Original means that is my V1 of a 2 molar solution. Here's my M1. If it has been changed, what we're changing it to is going to be our V2 and our M2. All right. So when we look at this and we look at our problem, remember our equation is M1 V1 equals M2 V2. All right, so go ahead and plugging those in. I have an M1 over here of 2 and a V1 that I'm trying to find. So 2 times V equals, here's my M2, 1 times my V2 of 5. All right, so then again, I have 2V, simplifying our 1 times 5 equals 5. How do I solve for V? Divide by 2 on both sides. So my volume, 5 divided by 2, V equals 2.5 liters. That's your answer. All you're doing is solving for that missing variable. All right. And now let's take a look at your last example. What is the new molarity? So I'm looking for, it's the new one. So M2 of a solution that has been diluted from, meaning this is what we started at, from 100 milliliters, there's my volume, and 1 molar. So there is my M1 and V1. And I diluted it to 250 milliliters. So that's what I changed it from. I went from 100 to 250. So there's our V2. So going back, we know our equation up here at the top. We're going to plug that in. I have a M1 value here of 1 times V1 of 100, which equals my M2 that I'm trying to find times my V2 of 250. All right, and so then I'm going to simplify 1 times 100. So 100 equals M2 times 250. How do I solve for M2? I need to divide by that 250 on both sides. 100 divided by 250 is going to give me my M2. So over here to the side, M2 equals 100 divided by 250 is 0.4. All right, so your new molarity once you dilute it out would be 0.4.